You are watching Earth Sky, and I'm here with Michael Brown, who is a professor of astronomy at the California Institute of Technology. His 2012 book is called How I Killed Pluto and Why It Had It Coming. He also helped discover the Kuiper Belt, which, for those of you who don't know, is similar to the asteroid belt, but way, way, way more massive. So in early 2016, Brown and a colleague began searching for another major planet in our solar system, and they call it Planet 9. Hi, Mike.
Good morning.
How are you?
I'm doing great. Thank you for having me.
Oh, thank you for coming. Let's talk about Pluto. So
Okay.
Pluto lost its full planet status in 2006 to a huge uproar.
I would like to say that Pluto lost its planet status when it failed to get big enough to be a planet back about 4.5 billion years ago.
Okay, explain that then.
Well, it's really not that we ever changed our views of what a planet is. It's that when we first discovered Pluto was discovered in 1930. If you go back to the New York Times headline of the day of discovery, front page, it says, "New planet found, possibly larger than Jupiter." And this is wrong by about a factor of 250,000. And it's for that reason that, of course, if we found something larger than Jupiter out there beyond Neptune, nobody would argue about it being a planet or not. And because it was thought to be large, it was immediately called a planet. And it was that slow drip of realizing it was smaller and smaller and smaller, and then realizing there are many other things like it that made us realize not that we changed our definition of planet, but that we should never have called Pluto a planet to begin with.
Right. So it's just a matter of we didn't know. But before we talk about those many other things like Pluto,
Yeah.
did you get mail?
Oh yeah. I got hate mail, email mostly, but not always. I got some really fascinating, obscene phone calls late at night, luckily to my office, so it didn't wake me up, where they used words that I didn't know what they meant, so I had to ask my grad students, and they laughed and wouldn't tell me, so it must have been bad.
It was bad. It sounds
It was
like it was
bad.
bad.
It was bad.
So, like, why do you think that happened? Why did people get so
I
upset?
I actually understand this emotional connection to what we think of as our neighborhood. If you talk to most people, people can explain where they live, all the houses around them, the city they live in, maybe their country, and then you start to ask them what's bigger, and most people can give a pretty good accounting of the solar system and the order of the planets and the sizes of the planets, and you say, okay, what's after that? And then that's kind of it. This is about as big of the neighborhood universe that people understand. And if you suddenly take one of those things away and say, this thing that you grew up thinking was a major part of your neighborhood turns out to just be a moderately insignificant thing amongst many other insignificant things, there's an emotional reaction to that I 100% understand.
Yeah, and I mean, it's not just that Pluto is small and the other planets are bigger, but it's also that, that emotional reaction. It's like we probably can't go to any other solar system anytime soon, right? With our technology right now, well, like despite all the Star Wars movies and all the different sci-fi movies that you might see,
yeah,
we
no
don't have the
wormholes
technology.
Yet. Right.
Yeah.
Yeah.
Right. I mean, it would take, like I was reading a Kim Stanley Robinson book I'm reading right now, and a science fiction book. And he's talking about, if we even wanted to go to the next nearest star, it would take, even if we went some fairly, reasonable fraction of the speed of light, like say 5% of the speed of light, it would take hundreds of years to get to the next nearest star. So, our solar system is kind of it.
This is what we've got, and it's good that we're understanding it better now.
Yeah. So, so let's talk about that. So, I want to talk about, before we talk about the Kuiper Belt, I want to talk about the new planet definition that we heard about just last week. It came out from UCLA. And so what happened was that in 2006, the International Astronomical Union changed the definition of a planet, and that was the event.
Can I just say there never was a definition before, so they made one for the first time.
Okay, good point. Good point. So there never was a definition, so they made a definition of a planet, and that was 2006, and that's what caused the event that caused the whole uproar. So now there's being this new definition, newly proposed definition that came out of UCLA this past week. And why do we need a new one?
So I would say we don't, but actually I think that the new work from UCLA is interesting. So it's really less of a new definition as it is a way of explaining the definition that the IAU came up with. And so the definition that is now taught to every third grader in the country, of course, is that object has to go around the sun, has to be round, and it has to have cleared its orbit, which is a admittedly vague phrase that you can argue about exactly what it means. I don't think people really ever argued about it in good faith. Everybody understood what the concept was trying to convey, and yet
I don't understand it. What is
everybody? Okay, so everybody, the astronomers. Okay, so all of the concept that was trying to be described was that in our solar system, it is very obvious when you look at the planets. There are these 8 large bodies in circular orbits going around the sun, and nobody messes with them. At the same time, there are many, many millions of smaller objects flitting between the planets, being flung around by the planets, sometimes crashing into the planets. The planets don't notice. They just go around in circles and ignore these things. But these things are totally dominated by the planets, and the planets clear them out of their pathways and dominate everything. This is the very obvious concept that if you look at our solar system, you cannot escape realizing that there is a difference between these 8 things that are dominant and the millions of things that are not dominant. This is what the IAU definition was trying to get at, but it was, it was written at 3 a.m. before a meeting that started at 8 a.m. And I think that they could have spent a little more time and clarified it a little better, probably.
Yeah, I heard about that. It was really a last minute.
It was a little crazy.
Yeah, I heard about from Rich Benzel, who's another planetary astronomer.
Yeah.
So if Earth has cleared its orbit of debris, then why do asteroids sometimes strike us?
Yeah, so this is where the questions start to come in. It's like, well, clearly it hasn't cleared its orbit. It's not that there can't ever be an object that comes in, but you would say like the asteroid hitting us is part of clearing the orbit. It clears its orbit both by ejecting things and hitting them. If you look, there is nothing in the orbit, an orbit similar to the Earth, that lasts for very long. It will either get moved by the Earth, ejected by the Earth, or run into the Earth. The Earth, during all of this moving and clearing and everything else, doesn't even notice. This is the difference between a planet and all these things that aren't planets.
And the Earth and Moon, of course, are sometimes I hear them described as a double world. So we do have our large moon that sits there with us, and the moon doesn't get cleared out, although I guess it's getting farther and farther away every year.
It's not getting cleared out, but it's again, moons around the whole solar system. The moons are always dominated by the primary object. So this is the difference between moons and planets and asteroids. Moons are not asteroids. Moons are not planets. They are things in orbit around planets. You can also have moons in orbit around asteroids, around Kuiper Belt objects. But moons are, and this is a point that's made in this this study from UCLA. Moons are different, and I think we would all agree that we don't need the math to show that, but the math shows that moons are very different from everything else.
Right. And so, as a matter of fact, Pluto has 5 moons.
Right.
So that was one of the big freakouts that people, talked about when Pluto lost its planet status, but it's got moons. It's got, we already knew about Charon at that point, but more were discovered when New Horizons passed Pluto.
Actually, so they were discovered before New Horizons got there because people were really interested to make sure that New Horizons had a chance to look at everything that was known. And so they were discovered with the Hubble Space Telescope earlier. And so Pluto is not alone in having multiple moons and yet not being a planet. The large dwarf planet Haumea has at least 2 moons that we know of. Some of the even small objects in the outer solar system are little binary objects with another moon going around them. I don't even know how you would want to classify that. But so Pluto is interesting for having all these objects around it, but it's not anything that suddenly elevates it to planet status.
Yeah, so we here at Earth Sky are working on the update of Guy Ottawell's book, which is hopefully going to come out next year, The Astronomical Companion. And one of the things I noticed last night as I was updating the section on the planets is that Jupiter now has something like 149 moons or something.
I've lost track. Is that what it is?
Yeah, it's just like this huge number, and Saturn has even more. So I mean, it's just like, so the point I'm trying to make is we're discovering new stuff.
Yeah, and it's actually interesting on the let me just say on the Jupiter and the Saturn moons. So Jupiter has 4 major moons around it that are again big circular orbits. Then it has tons and tons of little debris that are in orbit around it that are called moons because they go around it. But it's a little bit analogous to the difference between planets and asteroids and small bodies is these major moons around objects like Jupiter and Saturn, and then the many hundreds of all of these, we call them irregular satellites because they're in all kinds of crazy orbits. And it's kind of the same thing.
Yeah, and so some of those probably aren't even stable, like you say. Some of them are probably going to do
eventually be
else.
gone, right?
Yeah. So back in the early 90s, I hear you were looking at Jupiter's moons when Dave Jewett and Jane Liu, is that her name?
Jane Liu, yeah.
Jane Liu discovered the first Kuiper Belt object, and you got interested in that, and then made some very huge contributions. So
yeah, Jane was in the office just a couple doors down from me at UC Berkeley at the time when the first Kuiper Belt object, when she and Dave discovered that first Kuiper Belt object, and it kind of blew my mind that there would be more things out there. And once you realize that there's even one object in the Kuiper Belt being small icy bodies beyond Neptune, kind of like you said at the beginning, analogous to the asteroid belt, which is between Mars and Jupiter, and rocky bodies. And it's basically the leftover debris that never quite got around to forming a planet. And so as soon as you know, Pluto was out there, and we, even back in 1992, it seemed weird, but it was just this oddball at the edge of the solar system. But then another object was found beyond Neptune by Jane and Dave. And then they found another couple more, then other people kind of finding some more. And within about a year or two, many of us who were paying attention just said, oh, okay, this is what Pluto is. It suddenly makes sense. Pluto is not an oddball at the edge of the solar system. Pluto is just the largest known member of this soon-to-be vast population of icy bodies in the outer part of the solar system. And that realization came true over the next couple of decades as more and more, I don't even know the number now, thousands, maybe above 5,000 now objects known in the Kuiper Belt, including ones approaching the size of Pluto and one that's even significantly more massive than Pluto itself. So it's this new, not quite unexplored, but still being explored region of our solar system out beyond Neptune. That's kind of an exciting place to be studying these days.
Yeah, and so there's the asteroid belt where we know over 1 million asteroids now, which is just kind of unbelievable.
Yeah, it's astounding.
When I started in astronomy, I mean, there were like just less than 10,000.
Right.
That were known, and so now there's like over 1 million, and then beyond the asteroid belt, there's Jupiter, and then there's Saturn, and then there's Uranus, and then there's Neptune, and then there's this other realm of these small icy bodies, the Kuiper Belt. And we've so far discovered, you said, what, 5,000?
I haven't even looked at the latest numbers, but I bet it's close to 5,000.
I've lost your sound, Mike.
I'm still here. Hello. I'm here. My sound seems to work.
We've lost Mike's sound.
Working on this end. It's working on this end. It's working on this end. It's working on this end. Hold with us,
guys. We're going to figure this out.
It's working on this end. Working on this end. Working on this end. Hello. 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 Anybody there? Hello?
Nope, it's me. Dave, are you here? And can you take over for a minute? I'll come back.
So you guys still hear me? Yeah, I hear you fine. So it's just her. So I'm going to just sit here and keep talking. Let's see. What was her last question? We were talking about the Kuiper Belt. I'm gonna freelance here for a minute until we figure it out. So we were talking about the Kuiper Belt. We were talking about those early discoveries. Up to 5,000 of them are known, something like that these days. And the big push for finding the new big ones happened in the early part of the 2000s. It's an interesting story because it came at the same time that everybody's getting cameras that they weren't quite these cameras yet, but cameras that were digital cameras. Hey. Are we back? We're still not back. I'm going to keep talking.
I am back.
So I'm going to talk about discovery, unless you have other questions for me. I was going to keep talking about these early 2000s discoveries. Okay, so in the early 2000s, as digital cameras, like we all had our little digital cameras that were getting increasingly better, the same thing happened in astronomy. And we finally got these digital cameras that were big enough that we could cover like a pretty big chunk of sky all at once, which let us cover the entire sky and look for any of the really large objects that were still known out there. So there was still a big difference between these small Kuiper Belt objects, and Pluto was really big. And so in the early 2000s, we started this large survey from Palomar Observatory down here a little south of me. And that's what really led to the discovery of these larger and larger objects, really culminating with Eris, which is significantly more massive than Pluto, has a moon of its own, really very far away. So sadly, we're not visiting anytime soon.
So what is the density of the Kuiper Belt like? Is it comparable to the asteroid belt? How far apart are these objects?
They are, so because the Kuiper Belt itself is so far away, even though the Kuiper Belt itself is many times, I forget the number off the top of my head, how much more massive it is, but many tens to hundreds of times more massive than the asteroid belt. Because it's so far away, the objects themselves are really far apart. So in the asteroid belt, as opposed to like Star Wars, where you're going through the asteroid belt, dodging asteroids the entire time, when we actually fly a spacecraft through the asteroid belt, like on the way to Jupiter or something like that, we desperately try to find one asteroid that's close enough that we might be able to take pictures of it as we go by on the way to Jupiter, and we modify our orbit a little bit so we can go right by there. In the Kuiper Belt, that would be nearly impossible. It is amazing that New Horizons went by Pluto and then got lucky enough to find another object that was close enough that they could modify the orbit and fly by that one object, Arikop. But the probability of flying out through there and even getting close to anything else is pretty small.
So it was genuine serendipity. So what about Planet 9? Where is it in the Kuiper Belt? Where is it?
Yeah, so Planet 9 is this new thing for which we're looking, and we know about its existence because of the Kuiper Belt, but it's actually well beyond the Kuiper Belt. So the reason that we first had a hint that things were out there is some people had been studying the most distant objects in the Kuiper Belt for a while and started to notice weird orbital patterns that were generally unexplainable. And in 2016, well, actually we started in about 2014. 2014, my colleague Konstantin Batygin, who's about 2 doors down from me at Caltech, he and I started looking at some of these orbital patterns and looking for more. And what we realized that had been overlooked before is that all of the most distant objects in the solar system, in the Kuiper Belt, these are objects that are part of the Kuiper Belt because they come in, I'll call it close. Close means only a little bit beyond Neptune. They come in close, but then they go really far away. They're on these very eccentric orbits that go like this.
Right.
And all these ones on these very eccentric orbits are all pointed off in the same direction.
So
and that's
something
weird.
is pulling them. Something
Well,
is pulling them.
something
them.
something has to be causing that pattern, because if there were nothing attracting them, even if you started them like this, they would very quickly move apart and just be sort of randomly. And we figured this out in about 2016, and we started thinking, okay, what could be doing this? And the obvious answer is that there's a giant planet out there, and we're like, that's stupid.
On.
We know
crazy.
there are no planets. We've all learned this in school. There are only 8 planets now. So we looked for all sorts of other explanations. Is it some gravitational pull from the entire galaxy? Is it the gravitational pull of the objects themselves? And we actually felt kind of bad because we couldn't come up with any other explanation. So we finally thought, well, okay, I guess we'll have to think about if it's a planet or not. So we started looking.
What other options did you consider?
We considered the galaxy, the full galaxy making a pattern. We considered that each of these objects is being pulled by each of these other objects. Maybe that's enough that they can align themselves. We considered that maybe there was no pattern. Maybe it was just we got lucky or unlucky, and we're looking at a random time and happened to notice these things. Yeah, and none of these worked, to our disappointment. So we started looking, and we were like, okay, let's write down some equations. Let's do some computer simulations. And, it turned out a planet works really well. And we thought, I don't know. Okay, that seems like there have been 35 or 36 other astronomers in the past 200 years who have jumped up and down and said they have found evidence for a new planet, and they're always wrong and usually semi-ridiculous. And so we're like, we
will not die.
Yeah, we're just not going to do it. And so we're like, okay, if there's really a planet, it would be nice to predict something else out there, not just like explain this pattern, but predict something else. And so we started looking, and we realized that there were a couple of interesting predictions. And if there's a planet, these things must be true. And they're all a little bit obscure. This is easy to explain. The other ones are a little obscure, but one that's less obscure is that these objects that are on orbits like this, sometimes a planet would twist their orbits this way or this way, and it would also twist them 90 degrees this way or 90 degrees this way. So suddenly the solar system it would almost look like it had wings going around it. And this is really would be a dramatic and easy to see pattern if it were true. And we're like, it's not true, so this must be wrong. And then we started doing more computer simulations trying to make that pattern go away. We couldn't get that pattern to go away. And I started looking at more and more data and realized, oh my God, I have overlooked this one whole set of data. And that one set of data had exactly these objects that we were looking for.
Gun.
So that was enough to us to write that original paper, to say, we really think there is this planet out there. Now it's time to go find it.
Could it be a brown dwarf?
It could absolutely not be a brown dwarf. So people have talked about a brown dwarf in the outer part of the solar system for a long time. We know a lot about this new planet now based on its how it's interacting with the objects that are out there. So we know that it's something like 6 or 7 times the mass of the Earth, which is way too small to be a brown dwarf. And we know it's about 500 times the distance of the Earth, or about something like 20 or 30 times the distance of Neptune. And if there were a brown dwarf at that distance, we would have seen it many, many years ago. Right. So we know it's a planet. It's smaller. It's less massive than Uranus and Neptune, but more massive than the Earth. It's in that intermediate, which is a really interesting area that we've been studying around other stars for the last decade, either these super Earths or sub Neptunes or something. We actually have one of these ourselves that we didn't realize was there.
So how are we going to find it? The math says it has to be there.
I would say the math says it is really, really, really likely it's there. I'm not going to go quite as be there, even though I think it has to be there.
Let's say should then.
So the only way to find it is to see it. Like you can do the math all day long and prove it that it's there, but until you see it, it's not there. It's not a planet that we have seen yet. And so you have to go look. So we've been systematically trying to find it for these last 8 years now. And you start out hoping it's a little bit brighter and a little bit closer than you think. And so you get a relatively small telescope and you search the whole sky. Didn't find it. Get a slightly bigger telescope, search the whole sky. Get an even bigger telescope. Now you start to hone in on the areas where you think it might be. And in the end, I think the answer to finding it is going to be the new upcoming Vera Rubin Observatory coming up about a year from now. Actually, it's been a long time coming, but in a year, it's a large telescope that's designed to scan the sky night after night after night. And this telescope is exactly what I would build if I were trying to build something whose job is to find Planet 9. So I really think it's going to have a very good chance of seeing Planet 9, which is the way you see it, is the same way that really William Herschel discovered Uranus all these years ago. You look at it one night, you look at it the next night, and all the stars are in the same place, and anything in the solar system moves by just a little bit. So we're going to be comparing images from night to night to night, looking for that thing that's moving just a little bit across the sky.
So Herschel, when he made his discovery, he had a name picked out. He wanted to name it after his patron, the King of England,
George.
Good old Planet George.
Planet George.
Thankfully, he got he got sidelined.
Yeah, the French didn't like that very much.
I can't imagine why. Do we have any contenders for the name of this?
So I would say that astronomers are a superstitious lot, and I give us the reason I think we are is partially because we're at the whims of the weather, and every astronomer that I know has their own superstitions about how it not be cloudy when they're observing, and so I'm convinced that it's the weather part. But one of my very strongly held superstitions is that if you come up with a name before you find it, you'll never find it, and so we have studiously avoided coming up with any sort of name for this planet until it's found. When it's found, we will come up with good ideas, and whoever finds it, they get the naming. They will get to be the namers, and we've a lot of people are looking, and we've tried very hard to make all of our predictions of where to look and how to look very public. So it could well be that somebody else finds it first, but I think only then should we start talking about a name.
Well, maybe we'll consider some female deities this time around. We could have Diana or Hera.
So these are all have been used for asteroids, and that's going to be one of the hard ones. Is that you don't want to reproduce an asteroid name, which is why when we found Eris is the most massive Kuiper Belt object out there, and it was the one that sort of led to the reclassification of Pluto, and so we were looking for a good name for it after it was found. And Eris, of course, is the goddess of discord and strife, and because of that semi-negative connotation, it was one of the only major gods or goddesses from the Greek pantheon that had never been used. And I again, superstitious. I'm convinced it was waiting there for me because it's such a perfect name for Eris, this one that led to this reclassification and all the big fights about Pluto. So we or somebody will come up with an equally good name for this new planet when it's finally found.
Excellent. So when it is found, you got the champagne on ice. How is this going to affect the astronomical community? Is it going to? Is it?
I think it's going to be a profound effect on the public and on the astronomical community in one very specific way. We have a new giant planet in our solar system that we can study, and so everybody is going to turn every telescope that they can think of to study it in every way. We've been studying giant planets for the past 200 years, and also every way that we've been studying exoplanets for the past 20 years. This is going to be an interesting connection between these two different populations, and so as much fun as discovering it is going to be, the science is going to come from studying it, understanding what it's like, figuring out how it got there, figuring out does it have moons, does it have rings, what kind of atmosphere does it have, what kind of history does it have. That's going to be where all the real excitement is going to be.
And we'll be able to translate what we already know about distant exoplanets back home, won't we?
And a little bit the other direction too. We'll be able to translate what we know about our own solar system planets out to planet 9, and it will be that connection to the outer to the rest of the galaxy too, which is, I think, it's just an exciting time to be finding all these things.
It's a brave new world, isn't it?
Absolutely.
We're boldly going. You know, Mike, I really appreciate you spending some time with us today. We'd love to have you back anytime. Folks, like the video, subscribe to the channel, come visit us at earthsky.org, and follow Mike. Mike, where can people keep track on what you're up to?
These
where
days,
can they get your book? Where can they get your book?
The book is available at your favorite independent bookstore. And every other outlet that you can possibly imagine, but go to your favorite independent bookstore. And you can follow me and the bears in my backyard mostly. These days on social media, I'm on Blue Sky. You can find me at plutokiller.com on Blue Sky.
Okay, there you go. Mike, thanks again. Folks, thanks for joining us. We've had a great conversation with Mike, and we'll see you back here next week for another conversation with today's working scientists. Thanks, Mike.
Bye, everybody. Thank you.
Bye.